Hey, everybody, welcome to your review for your first semester final for Math 1. First up, you have to know your exponent rules. A to the B times A to the C equals A to the B plus C. That means that if you have 6 squared times 6 cubed, that's 6 to the 2 plus 3. That is 6 to the 5th power. That's rule number 1. Rule number 2, a to the b all over a to the c equals a to the b minus c. That means that 6 to the 5th power divided by 6 squared equals 6 to the 5 minus 2, which is 6 cubed. Finally, negative exponents. If you have 5 to the negative 2, well, I should probably do the rule first. If you have a to the negative b, that equals 1 over a to the b. That means 5 to the negative 2 is 1 over 5 squared. That's supposed to be a 5. Always ugly. There we go. Okay, exponent rules. Great. Next up, how to graph. So if you are given a line, let's say you have a line of y equals negative 3/4 x plus 1. How do you draw that? Well, actually, you'll be given a couple graphs to pick from, but one way you can do it is just to see, like, if it's a positive, this is a negative slope, so I would pick a number that's going down, a line that's going down. If it's a positive slope, pick one that's going up. So, or the other way to know it is just to know how to draw it. So this has a y-intercept of 1, and I probably should label this first. It would also help if I could draw a straight line. That would really help. I was trying to get it to go there. So let's say that this is 1, 2, 3, and so on and so forth. -1, -2, -3, -4, -5, and 1, 2, 3, 4, 5. This is 1. This is bugging me. So we start with the y-intercept, which is 1, which I'll put right here. Okay, there's my dot. Then I have a slope of -3/4. That means a rise of -3 and a run of 4. Right? The top is always the rise. This is the rise. And this bottom here is the run. So you start with the rise. So we have a rise of -3. So -3 means we go down 1, 2, 3 right here. And then a run of 4, which means we go 4 to the right. So we go 1, 2, 3, 4 right here. Okay. So that means we went down 3 and we went to the right 4. I guess I could dot the line. Right, that's what we did, and so that gives me the line, which I just have to connect these. I'm not great at drawing straight lines, but that's what it would be. And so if they give you any other line, you know that it's wrong. So one way to do it is to look at the y-intercept, and another one is to look at the slope, make sure it's positive, negative. And if there's more than one answer choice that's positive or negative what you want, then count carefully the squares. Okay, conversion. Hopefully you know how to convert. Let's say we want to convert from minutes to hours. And the hint is that you always just multiply by 1. So let's say you have, I don't know, 900 minutes. And you want to convert that to hours. How many hours is 900 minutes? Well, always just multiply by 1. And don't forget your labels. What do I mean multiply by 1? Well, what is an hour in minutes? 60 minutes, of course, right? So I'm going to multiply this by 60 minutes. I'm going to multiply this by 1. And now the question is it 60 minutes over 1 hour or is it 1 hour over 60 minutes? And the answer is whatever one you're trying to cancel, you got to make it cancel. So the minutes has got to go in the bottom. So 60 minutes and 1 hour. This way the minutes will cancel. When you multiply, this will cancel with this, will become 1. And you're left with 900 hours over 60. Sorry for that ugly 9. Now you can simplify this. This is 90 hours over 6. Divide 90 by 6, and you get 15 hours. Whoopsie daisy. 15 hours. Next up, isolating a variable. So we want to make sure that we have a variable properly isolated. Let's say we have 4 plus 2 times x plus 3 equals 24. How do we solve? Well, I would actually first subtract the 4 from both sides. And I get 2 times x plus 3. And by the way, you should always try to do the problem. Finish the problem out before I explain it. Sometimes I forget to say that, but you should try and do the problem before I do it. Because right or wrong, whether you get it right or wrong, or whether you think it's impossible or you're almost this close to getting it, the struggle helps you learn. And it is necessary for learning deeply. And so don't neglect to actually try. So we're going to multiply these, and we're going to get 2x plus 6 equals 20. And so that means that 2x equals 14, and x equals 7. Next up is area model. I think I can fit that on the same page. So we are going to have a binomial. We're going to have like 2x plus 7 times 3x minus 5, something like that. And they want to know what that becomes when you simplify. So that's a question of area model. So what we do is there's 2 terms in the first one, in the first bracket, and there's 2 terms in the second bracket. That means it's going to give us a 2 by 2 grid. And then I just put in what I want. And it doesn't matter which one I pick to be, if I want the first one to be the top or the left side. As long as I keep these together, it'll be okay. 3x times 2x is 6x squared. 3x times 7 is 21x. 2x times negative 5 is minus 10x. 7 times negative 5 is negative 35, and that becomes 6x squared. These two are friends. They get together. They're like terms. 21 minus 10x is 11x positive minus 35. And that is how you do the area model. All right, let us keep going. Let's say that we have a chart. Okay, we have a chart and we have let's say hours. And then we have liters, some liquid. And after 1 hour, after 2 hour, 3 hour, and 4 hour, And let's just say it's 3, 9, 15, 21. And they want to know if we can make a linear equation out of this. So can you make a linear equation out of this? Why don't you go ahead and try? So this is kind of like having, here's the solution. This is kind of like having, you pick two coordinates. So you can say 1, 3 and 2, 9. And what you have then is you have 2 points, and you can use the slope formula. And so I will actually try to color code these. This is going to be x1. This is going to be y1. This is going to be x2. And this is going to be y2. And so this is y2. This is y1. This is x2. And this is x1. And so I just fill in those numbers that I have. And so I get y2 was 9. 9. Let me just put this here. Minus over this. Y1 was 3. X2 was 2. And X1 was 1. And this becomes 6 over 1, which is 6. That means this is my M. And maybe you could have already told that because you knew they were going up by 6 each time. But that's your slope. What's my y-intercept? It's tempting to say 3. But actually, that's after 1 hour. And we need the 0 in order to find the y-intercept. So in other words, if I have y equals mx plus b, and I know that the m is actually 6, and I plug in a point. Let's say I plug in this point right here. I would have 3 equals 6 times 1. Plus b. Subtract 6 from both sides, and I get minus 3 equals b. So that means the answer is y equals 6x minus 3. The y-intercept would actually be negative 3. Okay, related to this problem, you're going to have a couple of questions that ask you to find the slope given 2 points. So this is definitely an example of how you can find the slope given 2 points. You're going to need the slope formula here if you have 2 points and you need to find out what the slope is. You can use the slope formula for that. Okay, let's talk about parallel and perpendicular lines. So let's say you have a slope, line I should say, y equals 3/4 x plus 2. And they want to know what's a parallel line. Why don't you try telling me, writing down a parallel line to this one. Go. All right, here's the answer. Any line that has 3/4 x, any line that has 3/4 as its slope is going to be parallel to that other line. So the y-intercept doesn't really matter. It could be 1.78. I don't care what the y-intercept is. They're still parallel. Because if you have a line that's going like this and a line that's parallel like this, it doesn't matter how far apart they are. The y-intercept doesn't matter. As long as they're going in the same direction with the same slope, they're going to be parallel. So the y-intercept literally does not matter to see whether or not they're parallel. So parallel lines have equal slopes. Parallel lines have equal slopes. Well, perpendicular lines have negative reciprocal slopes. Perpendicular lines have negative reciprocal slopes. Why don't we use the same line to find a perpendicular line? Why don't you try to find one right now? Go. All right, here we go. So this is, remember we have y equals 3/4 x plus 2. Let's find a perpendicular line to that line. So that would be y equals, and we have to do two things. Flip the slope and flip the sign, meaning if it's positive, make it negative. If it were negative, then you make it positive. So this would be negative 4/3x. And again, the y-intercept doesn't matter. It doesn't matter what the y-intercept is. Let's make it negative 856.317. Just to be crazy. Right? Any y-intercept, I don't care what number you pick, doesn't matter. Still perpendicular. Because also like this, right? If they're perpendicular and they make a 90-degree angle, it doesn't matter if it's down here or up here. It's still going to be 90 degrees any y-intercept that you have. So you're going to have some questions on that about parallel lines. And then we move on to, we have another one about solving with fractions. Let's do that real quick. See if you can do this. So let's say we have 2/7 plus 3/8, and this equals x/28. They want to know what that would be. So what is x? How do you do this? Well, first you have to find a common denominator on the left. That would have to be 56. So we could multiply this one by 8/8. Multiply this one by 7/7. And what we would get is we would get 16/56 plus 21/56. I painted myself into a corner here, didn't I? That's 37/56. Which, if that equals x/28, we can multiply both sides by 28. And we would get 37/2 equals x. And that would be 18.5. Not super pretty, but it works. So there's more stuff about solving equations, kind of like one of the previous ones we did. So I'm not going to do another example because we've already done a few of those. Let's move on to something like plugging in a number into a function. So if you have some function, let's say, I don't know, 4x minus 3. And they want to know, this is a common question. They give you some input and they want to know what it becomes. So let's say they say, hey, if that's true, then what is f of 7? Huh? What is it? Try it. Go. Here's the answer. And if you don't try it first, you're not really going to learn that much. Watching the video, it's not going to help as much if you don't pause and actually try the questions I tell you to try. So let's assume that you tried it and plug it in. Let me make the number, give it a different color so we know what we're dealing with. So this is a 7, right? So we have f of 7. Well, that just means, as you can see, what happened is the x got replaced with 7. That means this x will also be replaced with 7. Any x will be replaced with 7. That's what a function does. 4 times this minus 3, and that becomes 28 minus 3, and that is 25. So what is f of 7? F of 7 equals 25. That's what it equals. So you're going to have some of those where you plug in a number into the function. All right. let's try this one here. Well, that's a tough one. Ooh. Okay, for that one I need the multiplication exponent rule. I don't think I gave you that one. That's right, I did not. That's a problem. I mean, these are great examples, but I was missing one. And so the one I was missing is that if you have some bracket and an exponent on the outside that it's like to the c power, that equals a to the b times c. And so that means if you have 4 squared cubed, that's 4 to the 6. 4 to the 2 times 3. And it makes sense because this is really 4 squared times 4 squared times 4 squared. And each one of those is 4 times 4 times 4 times 4 times 4 times 4, right? With dots in between, multiplication in between each. And that's 4 to the 6th. And so that's going to come in handy in some of these questions. Like if they ask you, hey, I have 4 to the 5th power squared, what is that? Well, that's 4 to the 10 because 5 times 2 is 10. Okay, let's go there. All right. So let's say you have $100 and you got to pay a bill. Let's say you have a subscription to some app and you got $100 in your account and the app takes a certain amount of money every month. And let's say you have 100, after 1 month you have 97, after another month you have 94, and then 91, and then so on and so forth. And so they want to know, can you make an equation for this sequence? You might already know that your common difference is -3, right? It's going down by 3 each time. And you know that your first term is 100. And so can we make an equation out of that? Yes, we can. So the nth term, a of n, equals, and there's a couple ways to do this, but you could just say minus 3n, because remember we have to have dn. And that's basically going to give you your slope with your y-intercept. So then you just have to find out what your 0 is. And I think I told you guys it's a minus d. And that is what it is. So it's dn plus a minus d. A1, I should say. A1 minus d. And for us here, a1 is 100, but minus d is -3. So minus -3 is actually plus 3. So this would be 103. If you're not sure about that, try it. Plug it in. What's a of 1? Plug in a 1 for n. Let's replace the n with 1. Minus 3 times 1 plus 103. What is that? That's 100. That's correct. A of 1 is 100. Remember, this is a of 1. So this is an arithmetic sequence, and how to find the explicit formula for an arithmetic sequence. It is given right here. A of n equals dn, meaning d times n, plus a1 minus d. And that's how you find the equation. Okay, let's go to the next one. Yes, this is a good one. So let's say you have some function, and let's call it f of x. And they tell you that it's, I don't know, 3/4. No, 3/4. Well, I just did 4/3. 4/3 x minus 5. And they want to know they want to know at what point this equals 3. So find the x value where f of x equals 3. How do you do this? Well, as you can see, these are the same, and so we can actually just substitute. And so this becomes 3 equals 4/3 x minus 5. And we can add 5 to both sides, and we get 8 equals 4/3 x. And we can multiply both sides by 3, and we get 24 equals 4x. And we can divide both sides by 4, and we get 6 equals x. And that is how you do it. So sometimes they ask you to find what, not plugging in 3. We're not plugging in 3 into the function. But they want to know what number would you plug into the function to get a 3. And it's a lot easier than it sounds, because all you have to do is set the equation equal to that number and solve for x, like we just did. Okay, we're moving right along. We're doing pretty good here. Let's see how much. We're about halfway done. Ugh. Although we've done some of these already. Graph the equation of a line. We already talked about that. Can you tell what an equation of a line is just from reading it? So what I mean is, let's say I give you a line. Can you tell what the equation is based off the line? I suppose it depends on how good I am at graphing clearly, because I'm somewhat limited. So let's say I have a line like this, and it starts here at 3, and let's say it goes down. Say it goes down here. Nah, let's go 1 over. Say it does this. Okay, and can you tell what the equation of this line is? Simply based on looking at the graph. And I should probably label some things here. So this one right here, that's ugly. I meant to make this 5. It doesn't look that way, but that's what I meant. This tick mark right here, it's 5. And this one up here, 1, 2, 3. This one's at 3. Can you tell what the equation of the line is based off of this graph? Well, you know that the y-intercept is 3, so that's a start. Y equals mx plus 3. Now you really just need the slope. And so if you can find 2 points, then you can calculate. So it seems to me that here's a lattice point. And so from there, you just have to calculate the rise and the run. Whoop, too far. And this would be the run. So the rise seems to be 1, 2. So that's minus 2. Rise equals minus 2. And the run seems to be 5. Run is 5. So rise over run would be 2 over 5. And remember that this is the slope. So that means the answer is y equals 2 over 5x plus 3. So you can tell what the equation of the line is based on the picture. That is another thing you have to do. Okay, is it a function? Yes or no? Those are always fun. So couple ways they're going to ask. One is from a picture, one is from coordinates. So first of all, if it's a picture, any graph that doesn't have dots on top of each other is okay. This one is fine. But if you have one where let's say, goes like this. You have dots on top of each other. Not okay. It's not a function, right? If right here, if we pass the vertical line through the green function, it hits at 3 points. It hits here, it hits here, it hits here. That's no good. It can only do it once. Like in the blue line, right? In the blue curve, if I do a vertical line, it only crosses one time. Now let's talk about how to tell from coordinates. And this is something that a lot of you, it's hard to remember how exactly this works. But let me just give you some coordinates. Let's see here. 2, 3, 5, 7, 4, 3. Let's start right there. Is this okay? Yes or no? Give me an answer. Write it down. Okay. Answer is this is okay. Because are there any dots on top of each other? No. But what about the 2 3s? I have different 3s, but with 1 2. Well, let's graph that. You don't believe me? Let's graph that. So we have 1 2 3 4 5. And we're gonna go up to 1 2 3 4 5 6 7. I guess I should have made this taller. 7. And so we have some dots, right? We have 2 comma 3, which is here. We have 5 comma 7, which is up here. And we have 4 comma 3, which is here. Are they on top of each other? No, they're next to each other. That's what it means to have the same y coordinate. They can have the same y coordinate. That's not a problem. It's a problem when they have the same x coordinate, because that means they're on top of each other. So if I added the point, let's say I added 1 comma 7, 1 comma 7. No, I'm sorry, not 1 comma 7. That's actually okay. No, I mean like 4 comma 5. Let's say I added 4 comma 5. So here's 4, and 5 would be right here, and this would be right on top of this one, and therefore it would be not okay. And the way you can tell is they have the same x coordinate but different y values. So same x coordinate, different y's. That means it's not a function. Anything else is okay. They can all have the same y value. That just means they're all next to each other. That's not a problem. But if and you can also have more than one dot that's the same thing. That's also not a problem. The problem is if you have the same x and you have different y's, that's when it's a problem. That makes it not a function. All the other ones are okay. Okay, some more exponent rules. Hopefully you can simplify and cancel. I'm not going to go over all those. There's some more area model. This one's a little longer, but I already went over that, so that's okay. Some more solving. They're all kind of mixed in. There's not like one section of just exponent questions, one section of just function, one just sequence. They're all kind of mixed together. And so I just got to make sure that I covered everything. Find coordinate axis below would be appropriate to use for this pair. It's kind of abstract. Which graph is this one? We already talked about graphs. We're almost done here, guys. We're about 3/4 done. Okay, let's do this. Some more sequence stuff. So let's say we have a sequence. No, we already did arithmetic ones. I want a geometric one. These are all arithmetic. That's good news though, because I know you guys like arithmetic better. Okay. More function stuff, which we already did. Okay, that's pretty much it. So one more time, what you got to do is you got to be able to isolate a variable, solving. You have to be able to figure out whether something is a function or not, either by graph or by coordinates. You have to be able to tell the equation of an arithmetic sequence, either to write it or to recognize it. You have to know your exponent rules because there's a couple of questions on those. You need to know how to graph a line and how to read a graph. That's really important. And slope and y-intercept and all that stuff. And that is pretty much it. That is the whole test. So I'm going to call this good. If you have more questions, let me know. I will see you guys Monday, Tuesday, and hopefully this is helpful to you guys. Thank you.